Uh, Today we just come to the slide. This is the slide module 1 and this is the crystal field theory we are discussing. Actually, I am requesting you try to join at dot 1:30. It will be better. Otherwise, when I go for presentation, it will be a little bit difficult. Okay. So we come to this section. Slides are visible, yes? My
Yes,
slides
ma'am.
are visible. Okay, but it is I am requesting you to please join at dot 1:30. Otherwise, it will be a little bit difficult because I have to admit this and I have to go for the presentation. So concentration breakup is there. Okay. So let us go for. I have already shared the slide to you. You know this thing. This is the representation. I am just repeat this one. Okay. So last class, I have discussed about the concept of the crystal field theory. And you know this thing that actually the shape of the d orbital is like this. If you consider the shape of the d orbital, you get the result that this is the dyz orbital, this is the dxz orbital, this is the dxy orbital, and these one dx square minus y square and dz square orbitals are there. So when you go for this presentation, you understand that I'm just going to develop another interesting and easy section using Paint software, how you can easily understand the shape of the different d orbitals. Just go through this. I am telling you. I think it is visible. This Paint software is visible. Is it visible? Yes?
Yes, ma'am. Visible.
Yes, ma'am.
Yes,
Yes, ma'am, it's visible.
yes, ma'am.
You just
Yes,
okay,
ma'am.
okay.
Yes,
Please,
ma'am. Yes, ma'am. Visible.
okay, no problem. I am just please off your microphone. I am just teach you want to teach you the how you can easily draw the dxy, dyz, dzx, and dx square minus y square and dz square orbital. What is the procedure? Okay, say, and this is you just choose any of this, say this is this, and you know this thing, it is very hard to write in this software. Say if we consider this is our z orbital or z axis, this is our x axis, okay, this is our y axis, and in that situation when I draw this axis, you understand that if we write down d x square dx square minus y square orbital. So where will be the lobe? You know this thing, dx square minus y square में lobe कहाँ पे आएगा? x के ऊपर रहेगा and y के ऊपर ही रहेगा lobe. So the lobes should be in dx square minus y square orbital. Lobes should be present either x or y. So this is the shape of the dx square minus y square orbital. Am I clear? Is it clear? So this will be only present on the x and y axis. Clear? Any doubt anyone regarding this? Any doubt? Anybody?
No, ma'am. No, ma'am.
No, ma'am.
Okay.
Clear, ma'am.
Ma'am, only
Okay.
on X and Y axis.
No, ma'am.
Only on it orbital lobe will be present only on x and y axis. If you think that this is, you just extrapolate this x axis and y axis, you get the idea that x and y, along the x and along the y, these lobes are present and z
Okay, ma'am.
में कोई lobe नहीं है. So this orbital is called the dx square minus y square. dy square. Clear? Am I clear?
Yes, ma'am.
Yes.
Now,
Yes, ma'am.
this is a really three-dimensional approach, so it is thoda visualize करने, it may be some difficulty it may arise. Now you can discuss that what will be the case for the dz square. dz square के लिए क्या होगा? We take this, okay, and remove this first of all. dz, please tell me, dz square में orbital का lobe कहाँ पे रहेगा? Please tell me, dz square में orbital में
On
lobe
Z
कहाँ पे रहेगा?
axis.
Along
Z axis.
exactly, very good. It should be in the z axis. If it's present in the z axis, so first of all, I am build up this axis. You just build up this one in your own way. That is, this is x. You may change this direction, no problem. But better if you, for different types of plane, etc., better if you write down in that way. So x, y, z is the coordinate. Okay, I am writing dz square orbital, and two lobes are present along the z axis. So how can we build up this one? Say this is z axis and d orbital is double dumbbell shaped. It is present here and x y में कोई lobe नहीं रहेगा. Am I clear? I think it is clear.
Yes, ma'am.
Any doubt,
Yes,
anyone? So
Ma'am,
you
the
just
ma'am, the middle one is not clear. Why did you draw that?
middle
Yes, ma'am,
one
yes,
means this one is actually dz square orbital जो equation से बहुत बड़ा mathematical equation से आता है. Actually last year तक ये syllabus आपका था. अभी it is not quantum mechanical calculation था. So that is why we expect a collar type in the dz square orbital. You just assume this is a collar and this is in the middle, but dz square का जो दो lobe रहेगा, two lobes will be present along the z axis. Two lobes should be present along the z axis. Am I clear? Am I clear?
Yes.
Okay. Now I am writing the most confusion generate hota hai when we go for dxy, dyz, dzx, and what will be the situation? How we can write down this dxy, dyz, dzx easily. So first of all, I am writing. Consider this one. Let me remove this. Okay. Say this is the situation. X axis is there, y axis is there, and this is the z axis. Okay. When you consider this is the x, y, and z axis, in that case, please remember, if I write down the concept of write down the diagram for the dxy orbital, क्या होगा? क्या बोला था क्लास में? In case of dxy orbital, lobes will be in between x and y axis. Lobes will be in between x and y axis. Am I clear? Is it clear?
Ma'am, in between x and y or on x and y?
No, not on x and y. dxy, dyz, dzx में क्या होगा? Lobes will be in between x and y. yz में क्या होगा? In between y and z. And zx में होगा in between z and x. But if you consider dx square minus y square, इसमें lobe कहाँ पे रहेगा? Along x and y. And dz square में it will be along z. Am I clear?
Yes, ma'am. Now it's okay.
Yes, ma'am.
So for dxy, if you consider in between this, say I just extrapolate this x-axis and y-axis also. Please tell me what will be the diagram for the, and now it is very easy, and I think you know this thing, xk in between x, that means x and y. Clear? Is it clear? In between x and y, this is also x-axis, and this is
Yes, ma'am.
also y-axis. So what will be the which will be the shape of this? Please tell me. Another should be in this, in between x and y. Another lobe should be in, if you consider this, it is this direction, another lobe should be, but no lobe will be present along the z-axis. And I'm simply build up this, and this is called the dxy orbital. Am I clear? Any doubt, anyone? Any question regarding this?
No, ma'am.
Now, if I consider dyz, dzx, you can actually, you observe this. This is present in the xy plane. This dxy, this is plane in the xy plane. Now, say as for example, what will be the situation for the dxz? Please tell me what will be the situation for the dxz. dxz के लिए क्या होगा बताओ?
Lobe
Ma'am, the
will
lobe will
present
be in between x and z.
Exactly. Very good answer. So we can write down that this is Z, this is the X axis, this is the Y axis. So if I write down, say a little bit for dxz orbital, what will be the situation for dxz orbital? So in between X and Z, in between X and Z. So where will be the orbital? Please tell me. X and Z axis, in between the X and Z axis. So what will be the situation? It is present in. So we can write down in that way. Clear? And it is along this plane, dxz. So three-dimensionally, we have to visualize this. And please remember that dxz means it present in the xz plane. It should present in the xz plane. Am I clear? Any doubt, anyone, regarding this? Any question? Anybody? Hello? Hello?
No doubt, ma'am. No doubt.
Okay.
Ma'am,
No
one
doubt.
second, please. Ma'am, one second, please.
Yes, please tell me. dxz में क्या होगा? X and in between x and z axis. So if you consider in between x and z axis, it should be in the xz plane. And it is, you observe that this geometry, that dx, it is present in the xz plane, not in the y plane. So we consider this is the dxz orbital. So we consider this is the dxz orbital. So simple diagram, I am considering that if you consider dx square minus y square and dz square, they are along the axis. But dxy, dyz, dzx are in between the axis. ये देखो कोई एक्सिस के बराबर नहीं है. These are not present along the axis. These in between the axis. But dx square minus y square and dz square are along the axis. Is it clear? Is it clear?
Yes, ma'am.
Ma'am,
Yes,
yes,
ma'am.
ma'am.
Okay. So,
Ma'am, one
हाँ
doubt.
ये बताओ बताओ.
I think there should be two maximum lobes between x-axis and z-axis.
Yes. Max between x and z axis to maximum lobe. What do you tell me that you just think that between x z plane, dxz should present in the xz plane, xy should present in the xy, dxy should present in the xy plane, yz should present in the dyz should present in the yz plane. So this is the situation. Now, if you consider, if you go for the diagram, you understand this thing, and the say so I am just representing you. You can understand this situation. This is the dxy orbital. This is the dxz orbital and this is the dyz orbital. And I'm just represent this one. Come to this part. Sure. So from this diagram, you understand this thing that dxy, dyz, dzx and dx square minus y square and dz square orbital, these are the general shape. And you understand that if you go through this diagram, you once more I am telling you that this is along the axis between x and y. This is along the axis on x and y. This is on the z axis, but here it is in between the axis, that is y, between y and z. Here it is in between z and x, and here it is between x and y. Now the question arises. Now the question arises, if you go through this, you understand that this is the why crystal field theory generated. Why crystal field theory generated? I think you understand this section, that when you, if I just write down the diagram, you understand that ligand is, when this is the dz square orbital. If the orbital is dz square and ligand is present here, ligand is present here, another ligand is present here. You may ask me that यहाँ पे तो ligand है, यहाँ पे ligand है, यहाँ पे ligand है. But if you consider this ligand and this ligand, one is out of the plane, another is below the plane. एक प्लेन का ऊपर है, एक प्लेन का नीचे है ऑक्टाहेड्रल जियोमेट्री में. तो जो लिगेंड प्लेन का ऊपर है, देखो ओ लिगेंड एंड dz स्क्वायर ऑर्बिटल का जो लोब है, वो दे आर प्रेजेंट along the axis. They are present along the axis. Is it? May I clear? Is it clear?
Yes, clear.
Yes, ma'am, clear.
I am writing this section another more time in the paint, and I think you can easily understand this one. And what will be the interaction, you understand. First of all, just go through this. Let us take the example. Say you just want to visualize this. I'm writing here. Say this is the dz square. I mean, first of all, I'm writing the octahedral complex shape. This is the octahedral complex. Say you understand this thing, that metal is in the central position. How many ligands are present in the octahedral complex? Please tell me how many ligands are present.
6.
Yes,
6.
6. And 6. And you, okay. You,
Yes, ma'am, 6.
Okay, off the microphone. And you understand that when you go for this interaction, I am writing here, this is the diagram for the axis. Say this is the z axis, this is the x axis, and this is the y axis. When I write down this is the z, x, and y axis, If I put the dz square orbital, what will be the situation? Dz square orbital should be in this direction. Am I clear? Dz square orbital should be in this direction along
Yes,
the
ma'am.
z.
Yes.
Clear? And ligand which is attached up and below, and the ligand which is attached up and below the plane. So if the ligand is attached here, another ligand is attached here. You observed, please understand this thing. This orbital lobe and this ligand are present along the axis. Is it clear? Is it clear?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am. Yes, ma'am. Clear.
Okay, this ligand and this orbital lobe are along the axis. Am I clear? And d orbital,
Yes, ma'am. Yes,
d,
ma'am.
d orbital contains electron. Ligand contains electron. d orbital के अंदर क्या है? इलेक्ट्रॉन है. लिगेंड के पास भी इलेक्ट्रॉन है. So दोनों इलेक्ट्रॉन का approach when come close together, there must be very strong repulsion because they are present along the axis. Clear? Because they are.
Ma'am,
Yes.
what did you say? The strong repulsive force.
स्ट्रॉन्ग इलेक्ट्रॉन के साथ क्या होगा? डीजेड स्क्वायर ऑर्बिटल के अंदर इलेक्ट्रॉन है और बाहर ऑक्टाहेड्रल फील्ड में बाहर से लिगेंड आएगा, तो लिगेंड भी नेगेटिव और इलेक्ट्रॉन वाला स्पीसीज होगा. बट डी ऑर्बिटल ऑल्सो कंटेनिंग द इलेक्ट्रॉन. सो दोनों, इफ दिस टू आर कम इन इंटरेक्शन वेरी क्लोजली, देयर मस्ट बी वेरी ह्यूज रिपल्सिव फोर्स बिटवीन देम. एम आई क्लियर? मेटल के पास क्या होगा? डी ऑर्बिटल का इलेक्ट्रॉन है, लिगेंड के पास भी डी ऑर्बिटल, लिगेंड के पास भी इलेक्ट्रॉन है. सो दिस टू इलेक्ट्रॉन विल बी रिपेल ईच अदर. इज इट क्लियर?
Yes, ma'am. You mean to say that the repulsive force will be in between the lobes?
In repulsive force, repulsive interaction between the metal d orbital and the ligand.
Okay, ma'am.
Am I clear? I am telling you, please think that this is the metal d orbital. I am not telling you that this is on the metal. Metal d orbital has electron and ligand also electron. When they come along the axis, there must be electron repulsion. But if the direction is along the axis, repulsion will be very strong. Is it clear? So if you consider dx square minus y square, and what is the situation for the dx square minus y square? The orbital shape is like this: x square, x direction, and fully on the y axis. So for dx square minus y square orbital, definitely we can consider this is the situation. This will be present here along the x and y axis. If it is present along the x and y axis, you get the idea that four lobes get along the ligand, get along the four ligand. This is one ligand, this is one ligand, this is one ligand, this is another ligand. So four ligands can interact with each other. So four ligands can interact with each other. That is why from this diagram, I think you understand this thing, the two orbital dx square minus y square and dz square are along the axis, and ligands also come to interact with them along the direction. Am I clear? Am I clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
But
Yes,
if you
ma'am.
consider what is the basic difference, and this is the origin of the CFSE, I am telling you that if the, just think, this is the d orbital and electron is present here and ligand come from this direction. So it is along the axis and repulsion will be very strong. Along the axis, repulsion will be very strong. So in case of dx square minus y square, this is the lobe. 4 lobes are present. The 4 ligands interact along the axis. 1 ligand, 2 ligand, 3 ligand, 4 ligand. Dz square, 2 ligands interact along the axis. But if you think dxy, dyz, and dzxy orbital, their lobes are not along the axis. Their lobes are present in between the axis. If you consider, say this is the your direction for the orbital is present in this direction and ligand is here. So interaction will be very strong, repulsive interaction. But if you consider orbital is here in between the axis and ligand is present here, interaction will be no such strong interaction will be there. Am I clear?
Yes. Yes, ma'am. Yes, ma'am.
Visualize, three-dimensionally visualize from the diagram, okay? So this is the situation if the axes are in between x, y, z. So the orbital should be go for this direction and ligand come here. So there is a lots of distance. But if the along the axis, so interligand and orbital d orbital interaction will be very strong, huge interaction, electron repulsion, and we can get the please tell me what will be the observation if the electron repulsion will be high, then the then the energy will be high, because this is not stability. This is not stability. Okay, repulsive interaction higher, so the energy will be high. And that is why dx square minus y square and dz square energy क्या होगा, increase हो जाता है, and this go for the state is called the EG. Stands for doublet and G stands for Girardet. Girardet means symmetric. Am I clear? Is it
Ma'am, this
clear?
last part will you repeat
Yes, ma'am.
once?
I will repeat. I will repeat this thing. If you go, I have already send you the study material, but when you go for three-dimensional visualization, it will be, you have to go for different approach. Otherwise, study material, it will be not everything is there, because this is two-dimensional approach. If you go through this section, you understand that dx square minus y square and dz square orbital, they are along the axis, their lobes are along the axis, but ligands are come with interaction along the axis. देखो ligand क्या है, octahedral geometry में ligand कैसे present रहता है, octahedral field में ligand ऐसे present corner में present है. This is the corner, ligands are present in the corner.
Yes, ma'am. In the
Corner and in the up the plane and down the plane. So if you get two types of this type of orbital which are projecting their lobes along the ligand, so their interaction will be very high. And if this interaction is repulsive interaction is very high, energy will be very high. And if you consider dxy, dyz, and dzx orbital, what will be the situation? Just think of this. And I'm go for the PowerPoint presentation, and I'm just come to this section. Say, as for example, this is the situation for dxy.
And the presentation is not visible.
I'll come to this point. Come to this. I think there is some issues are there. Net is there, but Meet Google is not responding. Show कर रहा है.
Hello? हेलो
मैम
हेलो
शायद रिस्टार्ट करने गई है।
हाँ हाँ, okay, okay.
ओ मैम आ गई।
Okay. So I am just representing the power section, PowerPoint part, and you understand this one. Say, I think it is visible right now. Yes?
यस
Yes,
मैम
ma'am.
यस मैम
Yes,
Yes,
Yes.
ma'am. That's very well.
Yes, ma'am.
Okay. So I come to this part. This is the, you understand what do you mean by the ligand interaction if it is present in between the axis. I am writing here, and I first of all through the power pointer come to this. This is the we are using the dyz orbital. Please tell me, dyz orbital means it will be present in the along the please anyone from the class it will
इन
dyz
बिटवीन एक्स इन
dyz
बिटवीन वाई एंड जेड
Y
एक्सिस
axis and Z axis.
very good.
Y and Z.
Very good answer. So we can consider.
In between y-axis and z-axis.
Very good answer. So if it is present in the y-axis and z-axis, we definitely consider this section. That means it is present in the plane, YZ plane. It is present in the YZ plane. And if it is present in the YZ plane, and say, as for example, this is the ligand. लिगेंड जो z एक्सिस के बराबर जो लिगेंड था वो लिगेंड दिस पोजीशन पे थे above the plane and another ligand थे below the plane थे. Just think, this is dyz is your plane. एक लिगेंड ऊपर में है, एक लिगेंड नीचे है. तो ये जो लोब है, these lobes are not along the axis with the ligand. Am I clear from three-dimensional viewpoint?
यस यस मैम यस मैम
But if you go through d orbital, dz square orbital, this orbital lobe and this ligand are present along the z axis. But in this dyz orbital, you understand that this orbital lobe and ligand is here. This orbital lobe is present here, ligand is here. In between the lobe, ligand is present. This is the ligand is present. So you can understand one thing very easily, that dyz. So if I just go through the pen and you can understand, I think much more easily. Pen. I just write down the dz square, dx square minus y square orbital, and you go for the octahedral geometry. देखो, this is the octahedral geometry. ऊपर में क्या होगा, दो लिगेंड रहेगा, ऊपर नीचे दो लिगेंड रहेगा, एंड ऑल द कॉर्नर में चार लिगेंड रहेगा. बट dz स्क्वायर जो है और dx स्क्वायर माइनस y स्क्वायर जो है, dz स्क्वायर कैसे रहेगा, यहाँ पे dz स्क्वायर शुड बी प्रेजेंट अलोंग द एक्सिस, एंड यहाँ पे क्या प्रेजेंट है, dx स्क्वायर माइनस y स्क्वायर ऑलरेडी प्रेजेंट है, बट दे ऑल आर प्रेजेंट अलोंग द एक्सिस. एम आई क्लियर? Am I clear?
यस मैम
Yes,
But if you go for dyz orbital, what will be the situation for the dyz orbital? This is the dyz orbital, but the diagram for the octahedral field का जो geometry है, this is the, I am writing the dyz plane, but octahedral field का geometry क्या रहेगा? This is the situation. Sorry, this is the situation. This is the octahedral geometry. it ऊपर में एक ligand आएगा, नीचे में एक ligand आएगा. This is the case, but ligands already present here in between the axis. It is not along the axis. This is present. देखो, दो orbital का lobe present है, but
मैम इन
a
बिटवीन
ligand
वाई
is
एंड जेड
in
एक्सिस
between the,
राइट.
exactly in between. This is the axis. So that is why you just go for this section, that this orbital dx square minus y square and dz square, dx square minus y square के पास इलेक्ट्रॉन है, dz square के पास इलेक्ट्रॉन है, but they are present along the axis in octahedral geometry. Ligand also present along this axis in the octahedral geometry. when ligand and dx square minus y square and dz square orbital come along the axis, interaction will be much more. But in case of dxy, dyz, dzx, these lobes are in between these axes, xyz. That is why ligand are not approaching along the axis. They are in between the axis. You just go for another diagram. You understand that these are in between the axis. dy, xy, in between the axis. In between the एक्सिस. सो इसके साथ दिस ऑर्बिटल लोब के साथ जो इलेक्ट्रॉन का जो इंटरेक्शन, दिस इंटरेक्शन विल बी नॉट सो स्ट्रॉन्ग इंटरेक्शन बिकॉज दे आर नॉट अलोंग द एक्सिस and their repulsive interaction is less, and that is why their energy should be minimum. Am I clear?
Ma'am, is this in case of dy yz?
dx, this is the case for, अब बताओ किस में in between the axis में आएगा ऑर्बिटल, बताओ dxy dyz and dzx में आएगा ना, विथ ऑर्बिटल का लोब का किस में in between the axis आएगा. तो लिगेंड क्या होगा, लिगेंड along the axis में इंटरेक्शन नहीं कर पाएगा. इफ लिगेंड इज नॉट इंटरेक्ट along the axis, एनर्जी विल बी मिनिमम, क्योंकि दोनों के पास along the axis अगर आएगा तो इंटरेक्शन विल बी वेरी स्ट्रॉन्ग. But it is if in between the axis. You can go for the diagram also. Say this is the ligand and this is the lobe. These are in between the axis. But here it is present along the axis. Strong interaction along the axis.
Yes, ma'am.
Clear?
Yes, ma'am.
So we yes.
Ma'am, I have a doubt.
है बताओ, कोई डाउट है बताओ.
Ma'am, in case of dz square.
Please write down in the chat box.
Okay, ma'am.
Write down in the chat box. क्या क्वेश्चन क्या है? ओके. Any question, anyone? Is it clear? Any question, anybody?
Yes, ma'am. Clear.
Clear. Okay. एक क्वेश्चन था ना, एक का बताओ, कोई भी क्वेश्चन, क्योंकि नेक्स्ट स्टेप वी हैव टू गो ना. ऑल क्लियर मैम? इन केस ऑफ dz square we will not consider the ligands coming from xy. Okay, very good question. Why we should consider x and y axis? Because we have to dz square means along the z axis. It is present in the along the z axis, so we should not consider here the x and y axis ligand. We have to consider the x and y axis ligand only for dx square minus y square orbital. Am I clear? Am I clear?
Yes, ma'am. So in case of dz square, the repulsion will be more, no, ma'am, more strong.
Why? Anybody please explain this? Why for dz square repulsion will be much more stronger than dx square minus y square orbital? Anybody from the class? देखो dz square orbital में, if you consider dz,
along axis.
but dx square minus y square orbital is also along the axis. These are present in the plane. Just go for this
And the
section.
ligand is present in the dz square.
Exactly.
So the repulsion will be more in that.
But dx square minus y square में x and y का लोब, x and y axis के ऊपर ही तो लोब रहता है. dx square minus y square में बोल रहा है. I am not considering dxy, yz, zx. Okay.
Okay.
dx square minus y square में क्या होगा? It will be lobes will be present along the x and y axis. This is the situation. अपेंट में जो ड्रॉ किया था ना, along the x and y axis.
Y axis, yes, ma'am.
है. So the 4 ligands will come along the axis. Interaction high. But if you consider dxy, dyz, dzx, these lobes are in between the axis. So ligand interaction will be minimum, and that is why from this diagram you understand this section that these two orbital, that means dx square minus y square and dz square orbital, which are present along the axis, has the same energy, and we have to guide it. Anyone from the class, please give me what is the name of this orbital? This two orbital का name क्या है? octahedral field में? Anyone from the class?
Ma'am,
Ma'am, T2.
EG.
orbital.
No, not E2. E2, this is the abbreviation we are using for only a tetrahedral complex, but we discuss here the octahedral complex. Okay, so this is for E. Small e stands for doublet. E का meaning क्या है? Doublet. दो स्टेट है, एक स्टेट है dx square minus y square, एक स्टेट है dz square with same energy. Okay, G stands for Girardet. And this state where the axes are not along the x, y, z, and ligand come in between the lobes of the orbital, so their energy will be minimum. These have this type of orbital. We can differentiate this orbital by three types of orbital are there. One is called the xy, another is yz, another is zx. So this is the situation. That means it is what is the name of this orbital? The set of this orbital का name क्या है बताओ? What is the name of this set? T2G. T stands for small t. T stands for क्या है? T क्या है? Triplet, because three orbitals have the same energy. G stands for Girardet. Am I clear? Am I clear?
Ma'am, E stands for what?
E stands for small e stands for doublet, and T small t stands for triplet. Okay.
Okay, ma'am.
Okay. Now I come to the that just go visualize this one. I have already told you in the paint. Go through this and you can observe dz square orbital. Z square का एक्सिस z square में dz square orbital में लोब कहाँ पे है? Along the z axis. Along the z axis. Am I clear? Is it clear?
Yes, ma'am.
Yes, ma'am. Yes, ma'am. Clear.
Just go through. It is the most important part from the if you not clear this one, you can't go ahead of this different topic. देखो, dz square orbital along the z axis. Now this is irrelevant if you consider that x and y में क्या ligand present है. Z में क्या है? These two lobes are along the axis and these ligand are present here. Ligand also present along the z-axis. Clear? Any doubt anyone regarding dz square? Hello?
No, ma'am. No, ma'am. No, ma'am. No, doubt.
dx square minus y square. I am writing here. dx square minus y square. क्या बोला था? X and along the x and y axis in the dx square minus y square lobes are present. Along the x and y axis, the lobes are present. If along the x and y axis lobes are present, so definitely you just write down this diagram that x axis के बराबर. पीछे भी x axis है, so this is the x axis, this is the y axis. But you observe this thing. In case of dx square minus y square, the ligands are irrelevant. Along which is present in the z axis. So we can consider that along the x and along the y axis, the ligands are present here is along with the d orbital lobe. Am I clear? Am I clear? Yes.
Ma'am, once more, please.
dx square minus y square में क्या है? ऑर्बिटल का जो लोब है वो कहाँ प्रेजेंट है? along the x axis and along the y axis.
Yes, ma'am.
तो ऑर्बिटल जो हम लोग जब देखो, this is the octahedral complex. Metal is present here. Metal is in the central ligand. One ligand up, one ligand down, and 4 ligands in the plane. जब dz square यहाँ पे प्रेजेंट हो रहा है तब क्या है? ऊपर का लिगेंड एंड नीचे का लिगेंड along the axis हो रहा है. नीचे वाला ligand and ऊपर वाला ligand are along the axis. But if you consider dx square minus y square, dx square minus y square orbital का shape है this is the shape of dx square minus y square. तो A बराबर कौन सा ligand present है octahedral में? Corner में 1, 2, 3, 4. 4 ligands are present. But if you compare dx square minus y square का जो lobe है and ligand जो है, they are along the axis. They are along the y-axis, they are along the x-axis. Am I clear? And this is also along the z-axis. Is it clear?
And ma'am, the ligands which are away from the lobes are known as irrelevant. No.
No, for the particular orbital, it is irrelevant. But when you consider the CFT, crystal field stabilization energy, for any of the metal and which containing all the d orbitals, you must consider all the ligand, or all the orbitals. But I am just saying that for dz square, what are the important factor? The factor ligands which are present in the along the z-axis. Here, the ligand which are present on the along the x and y-axis. This is the important part. Is it clear?
Yes, ma'am.
Now, another thing, you understand that for dxy, dyz and dzx, what is the situation? Most easily we can discuss this for dyz. Okay, most easily we can write down that for dyz. This is your octahedral complex. This is the octahedral complex. And this is the octahedral complex. In central position में क्या रहेगा? Metal. जो DYZ में जो यहाँ पे पावर पॉइंट का ये दिखा रहा है उसमें क्या है? We can consider this is the metal is present here. If metal is present there in the central position, then what happens? Ligand will be one ligand up, another ligand below. 4 ligands should be present in the plane. Am I clear? Am I clear?
Yes,
Yes, ma'am.
Just think dyz. When you think dyz, you just think that dyz orbital means the lobes will be present along the yz plane. The lobes will be present along the yz plane. Am I clear? So this dyz, the lobes are present along the yz plane. And if it is present in the along the yz plane, we can consider that it is also in between the y and z axis. It is also in the between the y and z axis. Clear?
ma'am. In this case, along the y and z plane.
It is in the y and z plane ना. dyz क्या होगा? yz plane में रहेगा ना. This is the yz plane. And
Okay.
lobes will be present in between y and z axis. Lobes will be present in between y and z axis. Am I clear?
Okay, ma'am.
So if you consider ligand will present here upside का जो ligand था यहाँ पे ये this all ये वाला ligand below the ligand, this one. And the ligand which are present in the plane, this is also, these 4 ligands are there. But no one, not a single ligand are present here along the axis. Dekho, this is the y-axis, but lobes are present here. But this is the lobes and the ligand are present this axis. So this is the basic difference. This is not along the axis. There must be some difference between the ligand and the lobe, but here they are properly oriented along the axis. Am I clear?
Yes,
Is
ma'am.
it-
Yes, ma'am.
Is it clear? So any orbital, if you consider dxy, dyz, dzx orbital, the situation will be like this. That means dxy, dyz, just from the diagram, please give me the answer. लिगेंड के साथ जो लिगेंड यहाँ पे प्रेजेंट है एंड डी ऑर्बिटल यहाँ पे प्रेजेंट है, डी ऑर्बिटल यहाँ पे प्रेजेंट है, डी ऑर्बिटल के अंदर क्या है? देयर मस्ट बी सम electrons are there and ligand also contains the electron. So where we can get the maximum repulsion? Where we can get the maximum repulsion? Ligand and d orbital electron. Anybody from the class?
Ma'am, along the axis.
Along the axis. And what are the two orbitals? What are the two orbitals?
dz square and dx square minus y square.
Exactly. And why? The reason is that the d orbital electron and the ligand electron or ligand negative charge will take part along the along the axis, and the interaction will be higher and their energy will be high.
Minimum.
And क्या होगा?
Interaction will be minimum and repulsion will be higher.
Interaction minimum कैसे होगा? They are along the axis. If they are
Yes, ma'am.
present along the axis, repulsive interaction will be high.
ligand and lobe interaction
Lobe
will be
means
minimum.
along the axis में interaction minimum होगा.
Yes, ma'am. Ma'am, repulsion will be high, na?
Along the
I think
axis
so.
repulsion, just say in your exam or along the axis में क्या होगा? Ligand electron and d orbital electron are very close. Repulsion will be very high.
Yes,
Energy
ma'am.
will be high. Okay.
Yes, ma'am.
But in that case dxy dyz dzx में क्या होगा? The ligand,
Repulsion will be minimum.
this ligand or not a single ligand is present along the axis. They are in between the axis, so their repulsive interaction will be minimum and their energy will be lower. And you think this section, when you, this is the interesting thing, that generally you observed in your 11-12 level that d orbital has 5 types of d orbitals are there. They have the same energy, dxy dyz dzx dx square minus y square dz square. But actually when ligand ligand take part into action, we can get the result that the d orbital, due to their different shapes, they are splitted into 2 parts. One part is called the T2G, another part is called the EG, and it depends only for the shapes of different d orbital. Am I clear? Is it clear? Any doubt, anyone? Any question?
Ma'am, in case of EG, between dz square and dx square minus y square, which one will acquire the higher energy?
Actually, according to the crystal field theory and viewpoint, they have little. Actually, when you go for square planar complex, you understand this thing, Ian-Taylor distortion, etc. But generally, in this theory, the theoretician assume that their energy is almost closed. They have the almost same in energy, and these are also equal in energy. That is why they are present here in the same level. So in the EG level, and here it is present in the T2G level in the same level. But this difference will arise very deeply when we discuss the Ian-Taylor distortion. There must, we observe that there is some energy splitting. But if you can can't understand this thing, you can't, we can't go for the Ian-Taylor distortion. Is it clear? You just remember that what is the situation for along the axis. That means metal ka pass metal ki upar charge positive possible, but metal d electron should be negative. If d electron is negative and ligand come into an action, so electronic repulsion takes place, and if there is electron repulsion takes place, then we can definitely observe that there must be repulsion. If along the axis, repulsion is very strong. If in between the axis, repulsion is not so strong. If repulsion is so strong, we can energy will be increased, and this is the EG level. And if the repulsion is least, so this level is called the T2G level. Am I clear? Today's this splitting energy.
Yes, ma'am.
Yes, ma'am.
Yes,
Yes.
clear.
So
Yes, ma'am.
just for 5 minutes left, I am just discussing this one. When you get this result, and another parts of confusion, I just want to clear this one. If you go through this section, that you understand that this diagram, that one level is called the T2G, another level is called the EG. In EG level and T2G level, right now there is a difference in energy. Right now there is a difference in energy, and you know this thing. First, when I introduced this CFT, you ask me that you tell me that the CFT crystal field theory, the transition metal complexes are color, etc. The reason behind is that if you put the electron, one electron is here, it want to after gaining the energy, it want to go for this higher state, a higher energy level, and this transition, due to this transition, we can observe the color of the compounds or color of the transition metal complex. Am I clear? Because if you consider that if the energy level of the d orbital are same energy, we can't get the very colorful complex. But here the splitting between the d orbitals due to their shape along the axis or in between the axis, we get different color due to the electronic transition from T2G level to EG level or EG level to T2G level. This is a different issue. Is it clear? Yes.
Yes, ma'am.
Okay, so you just remember one thing, that this is the just important part. When you go for the T2G orbital level, this is called the dxy, dyz, dzx is present. And EG में क्या होगा, क्या क्या present है EG में? Please tell me what are the present, what are the orbital
D
present in
square
the
minus y square and dz
B
square.
square
dz
DZ
square.
square.
And the energy difference between these is called the crystal field stabilization energy, and it is guided by the term del O. O stands for octahedral. So this term is called the crystal field stabilization energy. And if you go for any good video lecture, any good book, Shiver Atkins is the book is there. But for your section, I am just prescribed that you read Prashant Roth. If you have the book Prashant Roth chemistry, you can read this CFT section from this. Okay. Hello. And you also read my study material also. I have already shared in the group.
Ma'am, what did you say the book's name?
Name of the book I'm writing in your Google
Okay, ma'am.
Classroom.
Okay.
I will give you everything. Okay, I will
Okay,
share the
ma'am.
code also today. So the difference between the T2G and EG orbital level is called the crystal field stabilization energy. And last thing, I just 2 minutes left. Few books they written this is plus 2 by 5. Few books they written this is minus 2 by 5. I will suggest you please put minus 2 by 5. If you consider this is the reference line, इसका नीचे अगर है this is minus 2 by 5 नीचे ज़्यादा stability minus, and if you put here above you just consider plus 3 by 5. But those the two things are correct. A few notation is this is plus 2 by 5, few notation is this is plus 3 by 5, but I will follow minus 2 by 5 here and upar mein plus 3 by 5. If you want to wish to follow my plus 2 by 5 niche wala, there is no problem, but I will follow minus 2 by 5 or minus 0.4 del O. So next class, yes,
Ma'am, what are these to this?
hello, yes.
Actually, ma'am, I was asking that what are these two? Means this 3
What
by
is
5 del O and 2 by 5 del O.
I will discuss it because 2 to 9 is there. Actually, I am telling you that my 2 by 5 means this is the energy gap, energy difference. That is, if you consider this is the reference line, the energy difference between the T2G and this reference line. कितना स्टेबिलिटी मिल रहा है T2G में, एंड हाउ व्हाट इज द इफ यू कंसीडर EG में एनर्जी हाई हो रहा है, दिस इज नॉट स्टेबल, कितना दिस अनस्टेबिलिटी मिल रहा है, दिस इज 3/5. दिस इज द नॉर्मल calculation how we can calculate the CFSE. So next class we will start from this slide. Okay, next class we will start from slide number 5 because there is no time right now. 2:30 is there. Okay, is it clear?
Yes,
Yes,
ma'am. Yes.
Acha,
What is
okay.
the today's exam
Okay.
code?
I'm sending, okay, your group, you just go through the BTech group section. I am sending the group code, and 5:30 is the time. 5:30 is the time, and I am repeatedly telling you, few student is not submit the assignment. Today is the last, I think 5 p.m. is the time for please submit the assignment for lab. Okay. Okay, thank you. Any doubt, any question have? Yes, please. Yes, please. Have. Thank you. Thank you. Okay, I am shared the exam code here also. I'm just shared this exam code here. If I have the exam code, I'm sharing here. Please write down the exam code. I'm just telling you and also sharing this 20 triple 0 9 006. This is the exam code. Recommended book for chemistry. Recommend in your if you go through the common book is in your syllabus. It is given Dhanpat Rai, organic chemistry. Dhanpat Rai chemistry is there, but you can't get the every details of the CFT. So you have to follow my study material, everything else. But for CFT, you can read this section from Proshant Rath and Shubhendu Chakraborty. Chemistry BTech book. Okay. And you can follow my study material. I think this will be sufficient for you. If you want to read, there are lots of foreign writer books also there. Another book is called the Shiver Atkins for CFT. This is a very good book, but this is not required to read so much. This will be very very problematic in that case. So either you can follow one book or follow my study material. Am I clear? Yes?
Yes, ma'am.
Okay. Any doubt, anyone? Any question? So I can leave the class?
Ma'am,
Okay.
excuse me.
Yes?
You said that in the difference between EG and that middle one, what did you say, ma'am?
T2G orbital. T2G.
No, means I'm asking that the middle part you have said something, the limit of something you have said, no, ma'am.
Limit of something means?
I think
Hello?
he's asking about the reference
How
line.
to show, ma'am, now?
Yes, please.
I think he is asking about the reference line.
Reference line.
Yes, ma'am.
Reference line means? कौन सा reference?
That, ma'am, you said that.
Reference line.
That is zero.
Okay. रेफरेंस लाइन इज देखो कोई भी लाइन है ठीक है सीएफएससी में ठीक है टुमारो नेक्स्ट क्लास आई विल डिस्कस दिस पार्ट रेफरेंस लाइन के ऊपर जो होगा दिस इज +3/5 नीचे जो होगा दिस शुड बी -2/5 ओके
Is it the difference between
बताओ
something?
ये है डिफरेंस बिटवीन
Yeah, same, ma'am.
if you call, I'm just give you one example. If there is just only one electron is present, system is D1. D1 सिस्टम है T2G D1 सिस्टम में ऑक्टाहेड्रल में T2G में कितना इलेक्ट्रॉन जाएगा 1 इलेक्ट्रॉन जाएगा T2G ऑर्बिटल में 1 इलेक्ट्रॉन रहेगा तो इसका एनर्जी हाउ विल यू कैलकुलेट T2G में just only 1 electron is present. So if you want to calculate the energy, you observe that this is T2G level में एक इलेक्ट्रॉन है एक के लिए एनर्जी क्या है -2/5 और -0.4 डेलो so it should be -0.4 डेलो into 1. Am I clear? Yes. Next class we will calculate the CFSE. Then it will be fully clear. Okay. And
Okay,
we will
ma'am.
start from the slide number 5 from next class. Okay. Okay. Thank you.